All right, we're looking at dot product today, first day of dot product, and then we got one more tomorrow. Here's the deal. When you take two vectors and you either add or subtract them, right, you will get a vector back. But when you take a vector, this little symbol, we always think of it as multiplication, but in this case, it's the dot product. So when you take the dot product of two vectors, you actually get a scalar number. So just basically a constant. We're still following the rules of i's with i's and j's with j's. So like when you add vectors or subtract vectors, remember you would add or subtract the I components, add or subtract the j components. You still do that, but instead of adding or subtracting, you're just going to multiply the numbers. So if I have two vectors u and v, and I want the dot product of u and v, I'm literally just going to take the i's, so 5 and -6, and 5, instead of adding them or subtracting them, I'm going to take 5 times -6, plus you do add the i's with the j's when you do this. Your j components are a positive 11 and a negative 11, so positive 11 times a negative 11, so we get a negative 30 plus a negative 121. Oops, sorry, trying to get a different color. Negative 121. And so the actual answer is negative 151. Notice that there are no i's or j's while I'm working with it. You don't actually write them out. That's not part of it. Remember, it's just a number. It's a scalar. So just another example. This one, instead of having two separate vectors, we have the same vector, and we're just going to do the dot product of itself. It's still the same idea. Your A is a 5, so you're going to do 5 times 5, plus your B is a negative 8, so you just do negative 8 times a negative 8, right? And so you've got 25 plus a 64, and so the dot product is 89. Okay? Onward and upward. So we've got three vectors this time. We want to do u times, u, the dot product with v plus w. So what we're really doing is we've got negative 6i minus 9j dot product with what's going to end up happening is I'll write it together. So remember, adding or subtracting vectors, you are just adding and subtracting the I components and the j components. So negative 2 plus 3 is a 1, right? And so this is really going to be 1i, and 3 minus 4 is going to be minus 1j. So v plus w, when I added those two together, when I added those two vectors together, I got another vector, and now I'm going to do the dot product. And of course, the dot product then is I take the a's, which are the I components, the numbers that go with the I, so negative 6 times a 1 plus negative 9 times a negative 1. And so I get a negative 6 plus a 9, right? And so then ultimately I get an answer of 3. Okay, same deal. Oh, no, sorry, not the same deal. We have two vectors this time. We're going to take and do a scalar multiplication, right? So remember, when you're multiplying by a scalar, you are literally just kind of distributing that negative 5. I'm going to distribute to the 9 and the 10 right there. So negative 5u would actually look like negative 45i minus 50j. And we're going to take that with the dot product, negative 3i plus 8j, right? So I'm just, again, I just want the dot product of those two vectors. I just had to modify the u vector a little bit. And so dot product, the horizontal components, so negative 45 times a negative 3 plus the vertical components, negative 50 times the 8. So I get 135 here plus a negative 400 here. So my dot product there is negative 265. All right, this next section deals with finding the angle between two vectors. To find that angle theta, we're going to do inverse cosine of, guys, the numerator is literally just your dot product. Okay, so it's just a dot product of the two vectors. And then your denominator is just going to be the product of the magnitudes. Okay. Okay. Now, a couple of things. If that theta is 0 or 180 degrees, that means your two vectors are parallel. If that angle is 90 degrees or pi over 2 or, you know, whatever you want to deal with, that means they're orthogonal. Orthogonal, I think I spelled that right. I don't think I spelled that right. Maybe I did. I don't know. Who cares? Nobody cares. Spelling doesn't matter. And if that theta is anything else other than 0, 90, or 180, then that means they're neither. Our problems in our notes don't require you to specify which one is which, but in your My Math Labs, you're going to have to do that. So that's why I wanted to take a minute right there to do that, or talk about that, I should say. All right, so we've got two vectors, u and v. We want to find the theta, the angle between the two. Okay, so remember, I mean, it's like if here's u, here's v, and we're looking for this angle, this theta right here, which is different than if we had just one vector, and like let's say that vector was here, and us trying to find the directional angle. That's different. Okay, so this is a little bit different, and it's not a big deal. You still just use that formula that you have. So the first thing I'm going to do is dot product u dot v, right? And again, remember, it's just a times a, -3 times a 5, plus the b times the b, so it's 6 times 2, and so that number is a -3. So my numerator is going to be a -3. And then I'll go ahead and work out the magnitudes and everything like that. So the magnitude of u is, remember, it's just the square root of a squared plus b squared. Oopsies. And I'm actually just going to leave it as a square root of 45. And you'll see why I leave it that way. And then the magnitude of v is just, again, the square root of a squared plus b squared. And so that's going to be the square root of 29. You don't have to break those down. So when you go to find the angle, theta equals inverse cosine of, and it's just going to be a big old fraction. In the numerator, you have the dot product, so it's -3. And in the denominator, you're going to have the product of the magnitude. So the square root of 45 times the square root of 29. Now, when you enter, and that's all you would have, well, I was going to start to say, oh, that's all the work you would have to show me, but since we're not really together and you're not like, haven't seen you guys in forever, so I'm not going to see your work on this particular unit. So that's all you would normally do. And then honest to goodness, you just go straight to your calculator and plug it in. And so that theta in degrees to the nearest hundredth is 94.76 degrees. And so these would actually be neither orthogonal nor parallel because, you know, it's not 0 or 180 and it's not 90. Okay, one more just to walk you through it again. And you don't have, like, I showed all the work in the separate parts for the last one, but you don't have to do that. That's totally fine. So theta equals inverse cosine of, and you can just do it as you go. Just be careful, right? Always try to write yourself a little bit of information. So dot product, remember, dot product is going to be -1 times 3 plus 5 times a -4. So it's really -3 plus -20. So the dot product is -23. Then we do the magnitude of each. So -1 quantity squared plus 5 quantity squared. Well, that's going to be 1 plus 25. So that's going to be the square root of 26. And then 3 squared plus -4 squared is the square root of 25. Now you can put it in there as a 5. That's totally fine because it is a perfect square and you can enter it like that. You can also just leave it as a square root of 25, and just when you do this, the nice thing is if you leave it as the square root, when you enter this denominator, all you have to do is hit the square root once and then just do 26 times 25. That's why I leave them as the square root. I don't ever write it as, if it's a perfect square, I don't write the whole number, and I don't ever break my square root down. You can just leave it like that. So when you plug it into your calculator, theta is going to be 154.44 degrees. So the angle between those two vectors, if I were to graph those vectors, if I were to do the geometric representation of those vectors, the angle between them would be roughly 154 degrees.